Hi everyone, welcome back. This is the first of the videos where we have the variable, the x, up on top. So it's up here instead of being 2x equals 8, which we've dealt with a lot of those cases. So this is really for senior courses. Some of you 10 students would have it, depending on their questions and what level they get to. The really simple ones you might even have for year 9. So let's have a look what's going on here. Australians refer to that as a power or an index. A lot of people in the world, they refer to it as an exponent. So they talk about it being an exponential equation. Let's have a look what's going on. You can look at that and just guess it. 2 to the y is 8, so you can go 2, 4, 8. And you can go, well, that's 2 to the 1, that's 2 to the 2, 2 to the 3. You could just say the answer's 3. Let's have a look at the method, which we'll need when it gets the harder one. Probably even by the time we get to these two. Most people can't think that one through, nor think that one through without having a method. So we're talking about the 2s, the 4s and the 8s. So these two numbers are in the list of what I call the powers of 2. And now I do love to say to people, I keep saying in videos, it's good to go home and go 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. By the way, it's pretty common in Western Australia to get numbers like 512, 1024 and 2048, and they will go into the non-calculator section of the exam. So knowing those numbers is really handy. The same for the 3s, but you don't have to go as far for the 3s. The 2s, let's have a look. So the 2, the 4 and the 8, 2 and 8 are there. So I can write the 8 as a 2 to the power of 3. When the bases are the same, so what we're talking about is that when the bases are the same, and there's only one term on each side, there's only one thing, if I want to call it a thing, one thing on each side. This is just a 2 with something on top. This is just a 2 with something on top. Then we can do what we call equate the powers. And that's what the whole technique's about, equating the powers. So once we've got a 2 with a something, a 2 with a something, we can just write the tops. We can write the exponents, we can write the powers, so that's just x equals 3, which you could have guessed anyway in the first place. So you can see the method works. So just one more just to make it a little bit clearer. So this time we got 3 and 9, so I've got 3, 9, I could keep going, 27, 81, and go through the numbers of these and write them all down. Good if you went through those, especially up to about 243 in your head, memorise them at night, go and sleep. And that's 3 squared. Now it's got the bases of 3, we're going to equate the powers, and we can just write that that's x equals 2. Of course we can go back and check it, 3 squared is 9. Now it's a little bit more challenging. It'd be interesting if you stop and think about it for a second and go, what would that be? I mean, I think I'd hesitate. For both of these I'd hesitate. I could think it through in my head and get the answer. Let's have a look. So we've got a 4 and an 8, so there's our 4 and there's our 8. So we know that in this list of numbers we're using the powers of 2. This question's all about the powers of 2. How do I write 4? Of course I can write that as 2 to the 2. Then the whole thing's got another x on the top. So a lot of people like putting brackets in and they go an extra x on the top. Whereas this number's here 2 to 3. Going back to this, it's a 2 to the 2 with another x. So we talk about it's a power raised to a power, or an exponent raised to another exponent. So what do you do with the power to a power? You multiply the powers. So that's 2 to the power of 2x. So a lot of people look at this and just go, well, it's 2 squared with an x. So there it is, 2 squared with an x. Pretty easy to do, you can get pretty confident at it. And that's 2 to the 3. So now we have the bases are the same. There's the bases are the same. We can equate the powers, so I can just write 2x is 3. And of course if you divide this side by 2, you divide that side by 2, and the answer's 3 on 2. Of course you could write 1.5 or 1.5. In Western Australia, 3 over 2 would be full marks, no problems, no need to change it, simplify it. Okay, let's have a look at this one then. Instead of using 2s and 3s, could have used 4s or 6s or 7s. I've gone to 5s, so this is actually 5 squared. Let me shortcut it a little bit. That's 5 squared to the power of x, so that's 5 to the 2x. I'll say it again. 5 squared, so there it is, 5 squared to the power of x. So what do you do with a power to a power? You multiply them. So there's your multiply just there. Then we write the other side as a 5, and the 5 by itself is 5 to the power of 1. Have a look what we've got now. The bases are the same, they're both 5. There's only one term on each side. Doesn't have any extras. If it had, for example, plus 1 over here, you'd have to get rid of that plus 1 and figure out what to do and muck the question up. But we'll look at cases like that in coming videos. Let's have a look at now. It's 2x equals 1. A lot of you will see the answer. You don't need to see any further. Of course, you can divide both sides by 2 and you've got x to the half. And you can have a look back at the question and go, well, it doesn't make sense to me. So what we're actually saying is 25 to the power of half equals a 5. So we know that a half means the square root of 25, which is a 5. And a lot of people are saying at the beginning won't see this. It's pretty obvious once you know what you're doing. So the square root of 25 is 5. There we have it. Now, guys, if you're enjoying it, please spread the word. Let people know. I'm also putting videos on other platforms, so you can check out my name elsewhere and catch up with what I've done. So at the end of my videos, I'm going to start putting this. A lot of people keep on saying, can you make extra videos on calculus, on trigonometry, all sorts of topics, factorization, and I want to just briefly show you a quick look at my channel here. So if you scroll down, you have year 7, class 7, and I've got this click here, so you can go across and look at a lot of the playlists, but often I have more playlists than what Google will allow me. Covers a lot of topics. So that's class 7, year 7, grade 7, first year of high school for a lot of people. And then class 8, and there's a lot here. Now, by the way, if I do click on that, you get an idea of how many playlists I've got. Well, there's so many. Equations, rates and ratios, it goes on and on. Now, a lot of my videos I have them in logical order, so once you open them up, you'll see there's like a beginning, very basic video going through to the harder concepts. So then you get the year 9 and 10. Now in Australia we have this unusual situation where year 10 splits up into 2 groups and we have an extension or an advanced class. So I've got a separate section for 9 and 10 which doesn't quite go so far as the 10A. So each of those go a lot further, and then you have at least lower level. Oh, by the way, I've got this one here. If you have a look at this one here called 1 Minute Maths. The 1 Minute Maths themselves are fantastic and helpful for people if you want to have a look at them. I've also got this, my recent best videos. If you want to help me with my view hours, which is what I really need help with, is if you go through and play some of those and leave them running and press like or make a comment or just watch them for your own sake. That's a really good way to get it going. I'll add more to it. Now we have a low level course called Essentials in Western Australia, and then we have one that's slightly academic called Applications. You can go look at the topics later. Then we have this, well, not unusual, it's probably the same in a lot of countries. We have a double maths. So if you pick the highest one, which is called Specialist, you got to pick the next lower one down, which is called Methods here in Western Australia. So if you have a look at the topics, this has got calculus, differentiation, factorization and graphs and all sorts of things. Of course you can click here and you get a lot more videos. Then it gets really serious, and that's called this Specialist Maths. That's where you, if I click on here, that's where you're getting logistic model, simple harmonic motion, 2D, 3D, vectors, complex numbers. That's the serious level maths. A lot of it applies to students at university, especially students in first year engineering, and they hadn't done the highest level when they were in year 11, 12. A lot of students are finding it very helpful there. Again, if you can get me some view hours on things, that'd be fantastic. Thanks for watching.